So in this video, I just want to review what I think you should know about trigonometry for physics. So the first thing you have to be able to do is apply the trigonometric identities to a triangle. So here we have a triangle right here. It's a right triangle. We know that because of this symbol. This is the angle we are given, and so we have to figure out what these sides are. So if this is the angle that is given, we can figure out that K is the hypotenuse. So I don't know if it helps you or not, but we'll just put in here, this is the hypotenuse, because it is the longest side. This side N over here, it is the opposite side. So this is opposite because it is opposite the angle. Here's the angle, and this is opposite it. And then the last one here is the adjacent side over here. Okay, so that's what those sides are. So when we apply the trig function sine, the sine of an angle is the ratio of the opposite side divided by the hypotenuse. So for this triangle, the opposite side is n, and the hypotenuse is k. So the ratio of n to k would be the sine of theta. The cosine of theta is the adjacent side. In this case, that is m, and we divide that by the hypotenuse, which is k. And then lastly, the tangent of theta is equal to the opposite side divided by the adjacent. So here's our angle. Here's the opposite side, n. Here's the adjacent side, that's m. So the tangent would be n over m for this. And remember, these trig functions, you can just look up in your calculator, right? Your calculator knows these ratios. So for example, if you want to know what the sine of 30 degrees is, your calculator will simply tell you that is 0.5. That means that if this was a 30-degree triangle, when you take the length of the opposite side and you divide it by the length of the hypotenuse, you will get 0.5. So remember, the sine of an angle right here gives you a ratio. So we can use this to solve simple problems. So here's an example. Suppose we have a right triangle, and we know that this side right here, this side, is 1.7 meters. We want to find the length of this side, and we want to find the length of this side. So let's give these some labels just so we can talk about them. Let's call this side over here, we will call it H, and let's call this side here B. Okay, now we can apply the trigonometric definitions. So the sine of the angle, the sine of 32 degrees, will equal the opposite side divided by the hypotenuse. So here's my angle. H is opposite, and 1.7 is the hypotenuse. So this is going to be H divided by 1.7 meters. And so that's an equation. Your calculator knows what the sine of 32 is, and you know 1.7, so you can solve this for h. So to get h by itself, we multiply both sides by 1.7, so we'll have 1.7 meters times the sine of 32 degrees, and you can work that out on your calculator. Okay? Now, if we wanted to find this side right here, this side B, then we would probably use cosine, because the cosine of the angle, 32 degrees, is equal to the adjacent side, which is B, divided by the hypotenuse, which is 1.7 meters. And we could then multiply both sides by 1.7, and so we could find B, which would actually equal 1.7 meters times the cosine of the angle, which is 32 degrees. So I guess I could put in 32 degrees there. Cosine of 32 degrees. And we could solve for B. And then once we have H and B, so once we know H, once we know B, we can answer other questions. For example, if we ask for the perimeter is just the sum of all the sides. It's the distance all the way around the outside of the triangle. And so the perimeter would be H plus B plus the hypotenuse, which is 1.7 meters. And these are all things we know, so we can find the perimeter. If somebody asks us to find the area, the area is 1/2 the base, which I called b, times the height, which I called h. And since we know b and h, we can find the area. So I might ask you to find the perimeter or the area of a triangle just to make you find the edges. And then the last thing I want to show you is that for a right triangle, if this is our right angle down here, then this angle right here and this angle right here have got to add up to 90, because the interior angles, all three angles, have got to add up to 180, and this one's already 90. So because we already know this guy here is 90 degrees, then we know that the other two must add up to 90. So if we wanted to find that other angle, we could call it, I don't know, we'll call it alpha. Then what we know is that 32 degrees plus alpha have got to equal 90 degrees. And so we can subtract 32 from both sides, and we can find alpha. It will be 90 degrees minus 32 degrees. And we call those two angles complementary because they add up to 90. So that's how we're going to use trigonometry for basic right triangles. Okay?